We're starting off with a review chapter. These are all skills that we should have coming into this class. So we're just going to go over them before we get into chapter 1. Today we're talking about opposites and absolute value. So we're going to use opposites and absolute value. On the warm-up, we are naming the point that is the graph of the given number. So for number 1, we've got negative 2 5/8. Where is that on the graph? Which letter is near that number? Okay, point E, letter E. Number 2 asks us for the point that is at negative 2/10 or negative 0.2. What point is that? C, good. So it's just barely in the negatives. And number 3 asks us for 2 1/4 or 2.25. Point D. Not very exciting that it goes in order, but they're all there. Remember that a number line should always have 0 on it somewhere. Negative numbers count backwards or to the left from 0. Our positive numbers count forward or to the right from 0. Paired points on the number line that are the same distance from the origin but on opposite sides of the origin are called opposites. So one example would be something like 5. What's 5's opposite? Negative 5, good. You could draw a number line and show that they are the same distance away from 0, but I think many of you already know that. What about the opposite of negative 2? Positive 2, good. Okay. The last one, you could come up with any example you want. So I'll put 3.14. What's its opposite? Good, negative 3.14. So you can start with a positive and its opposite is negative. Start with a negative, its opposite's positive. They could be whole numbers, decimals, fractions. Any real number has an opposite. What about the opposite of 0? 0. I would get that either you could put it in the example side or the notes side. The opposite of 0 is 0. It is its own opposite. Now this is related to but not the same as opposites. The absolute value of a number is the distance between the graph of the number and the origin on the number line. The distance between that number and 0. All right, so some of this is more in the notes column. So I'll kind of put brackets around stuff that's more note-like, and then you can see the examples would go next to them. Again, these are your notes. However you prefer to organize them is up to you. The absolute value of a number is denoted by the bars around the A. So these bars denote absolute value. If A is positive, then the absolute value of A is A. Now, if it's negative, there's a small typo on here. The absolute value of negative A is still positive A. And if A is 0, the absolute value of 0 is 0. Basically, what this is telling us is that absolute value is always positive. It's talking about a distance. It's always going to be positive. So the absolute value of 8, what's it going to be? Absolute value is always positive, so it is still just an 8. It's 8 spaces away from 0. What about the absolute value of negative 8? Also 8. Even though it's a negative 8, it's 8 spaces from 0. Absolute value is distance. It's always positive. And last but not least, if a is 0, then the absolute value is 0. You don't have any distance to get there. All right, so now we're just going to do some examples mixed together. For now, our directions are state the opposite of each number. So if I'm doing this in my example section of my notes, I would put the directions and maybe draw a big line underneath it. State the opposite of each number, so that way I know what the directions were. If you just write down 3, -7, 0, and then put the answers next to them without the directions, it might not make a whole lot of sense later on. What is the opposite of 3? -3. What is the opposite of -7? +7. The opposite of 0 is 0. Again, I would potentially put the directions of simplify next to or before this section of examples. These ones are a little more clear because they should start off with those bars. What do those bars stand for? Not opposite. Absolute value. Good. Those bars stand for absolute value. What is the absolute value of 5? 5, good. Absolute value is always positive. If you want to put an equal sign on these, you can, because we're simplifying them. We would not have put an equal sign next to opposites. Opposites are not equal to each other. What about the absolute value of -2? A +2, good. And the absolute value of 0 is 0. On number 7, am I taking the absolute value? No, I don't have bars. Instead, I have parentheses. Now, we haven't covered order of operations yet, but we are going to simplify inside the parentheses first. So if I simplify inside the parentheses, 3 + 2 is 5. The negative sign outside would read the opposite of 5. If you want to write that next to it, that's what this means. The opposite of 5. Oop, no. There we go. That's how we should read that out loud or in our heads. And we know that the opposite of 5 is just good, -5. So that would be my answer. So how would I read number 8 out loud? See if I can learn some names. Caitlin?
The opposite of -3.5.
Beautiful. we would read that to ourselves or out loud as the opposite of negative 3.5 or 3.5. What is the opposite of negative 3.5? Positive 3.5. So again, if you want to write it out in words so you know how it should be said to yourself, the opposite of negative 3.5 or 3.5. That's how we should be reading that to ourselves. The opposite of a negative is, of course, positive. All right, on number 9. Now, what are we looking at? Those bars mean absolute value. So we need to do both of these absolute values first, and then we can add them together. What's the absolute value of negative 4? 4. The absolute value of 7? The absolute value of 7 is a positive 7. Now we can add those together. What do we get? 11. Do not add them together if they're in different sets of bars until you've been able to drop the bars. If you add negative 4 and 7, then take the absolute value, you're doing something completely different and getting a different answer. All right, this next set of problems has the directions of evaluate if t equals negative 4. When we evaluate, in general, we substitute, then simplify. Or some people call it plug in, then simplify. Evaluating is something that we will be practicing a lot, especially in this review chapter. The first step is always to plug in. So instead of writing a t, what am I going to write? Negative 4. Nothing else is changing. So those bars stay. Instead of a t, I write a negative 4. Now we're ready to simplify. The absolute value of negative 4 is 4, and that is my answer. Nothing else to do. Number 11, again, I plug in, then I simplify. But I am not changing anything except for the t. So that means that the negative sign out in front of the t is staying there. I am going to put parentheses around the negative 4 this time, just to separate it from the other negative sign. The plus 9 is also staying the same. Who can tell me how to read this problem out loud now? Or at least the first part of it. Lydia? Good. The first part of it is the opposite of negative 4. That's how we should be reading that. What is the opposite of negative 4? A positive 4. And then what are we doing to that 4? Adding 9. 4 plus 9 is 13. So that's what we should be getting as our final answer. Yes, I should see your work. Anything I write, I would expect you to write. So if you're not writing down what I'm writing down, you need to start practicing showing more work. All right, on number 12, again, our first step is just to plug in. So everything else about the problem stays the same. I'm plugging in a negative 4 for t. and then I'm evaluating it. Now this one I am going to write out how we would read it. The negative sign out in front means I'm taking the opposite. So this is the opposite of, what do those bars mean? Absolute value. So we're taking the opposite of the absolute value of -4. So that means we've got to do two things. We need to take the absolute value and then take the opposite of it. So I'm going to rewrite it up here at the top, just so I've got some space. What is the absolute value of -4? 4. What is the opposite of 4? -4, good. So the absolute value turned the 4 inside those bars into a positive, but the negative sign on the outside meant we're taking the opposite of it, so it goes back negative. You got to be able to keep track of your positive and negative signs. What did we get for an answer on 13? Did anybody answer 13? Caden? 0, good. So 12 minus 12 is 0. The opposite of 0 is still 0. So that should have been our final answer. Now number 14, especially if you're in the back, might have looked a little challenging. These are brackets, not absolute value bars. So if that changes things for you, these are brackets, not bars, which means they work like parentheses. So if I were to read this out loud, it would be the opposite of the opposite of 4. Lydia? You're on the right track. So the opposite of 4 would be -4. But then we want the opposite of that. So we're taking the opposite twice. We end up back at, I think somebody said it, 4. So the opposite of the opposite, it's kind of like 2 negatives multiplied to be a positive. Hopefully that's something we remember. Okay, we would end up back at a +4. Now 15 does have the bars, so that is absolute value. The absolute, well, did anybody get the answer? We'll go there first. Alex? 3, good. We get 3 as our answer. Absolute value is always positive. So we take the absolute value of both of those and add them together to get 3. Questions, concerns about those examples? I know we have a lot of examples today. They're meant to go pretty quick. Okay. We have a couple of these that we're going to try out. I know that it's a little bit long to write these as examples, but we are going to be taking these words and turning them into mathematical phrases using symbols. So I would write out the words, and then we are going to turn them into symbols. Okay, what symbol tells us that we're using absolute value? How do we know it's absolute value when we see it in symbols? the lines or those bars. So if we're talking about the absolute value of 6, we need bars around the number 6. I make my bars nice and long. You might even want to write the number first, so that way you make sure the bars are taller than the number, so it doesn't look like a 1. Is less than. Does anyone remember the symbol for less than? Lydia? Good. Yep. So some people refer to it as the alligator mouth, which we're in high school. We might move past that a little bit. So this is our symbol for less than, the little arrow pointing to the left. Less than the absolute value of negative 20. So again, we have a negative 20 and we put those bars around it for absolute value. And this is a true statement because if we evaluate the absolute values, 6 is less than 20. You don't have to do that, but it is a true statement. All right, 17, the opposite of negative 3. Now, based on some of our previous examples, how am I going to show the opposite of negative 3? Desire, do you know how to do it?
With a bar.
We're not going to use bars. So it would evaluate to 3. But if I started off with a negative 3, what symbols could I use to talk about the opposite of it? Think back to some of our other examples. Oscar? You're right. It turns out positive later. Lydia? So I want to put symbols around this negative 3. Caden? Parentheses around it with what else? What on the outside? A negative on the outside. This is how we show the opposite of negative 3 in symbols. Okay, now greater than, for that next symbol, is greater than. That flips that arrow around to the other way from less than. The opposite of 2. Now again, some people just want to write it as negative 2, or you could put the 2 in the parentheses. I would be okay either way there. But for the opposite of negative 3, we do need it written with those parentheses and another negative outside. Questions about writing this in symbols?